Hi everyone, so this is the chapter 25 lesson on isomers. So we have seen this prefix before, the prefix iso. If you remember the term isotopes, that's where the number of protons remain the same, but then the neutrons varied, so then they had a different mass, okay? Now in isomers, that means that something will remain the same, and the thing that remains the same is the chemical formula. Okay, or what we also consider as the molecular formula. So the formula is the same, meaning it contains the same number of carbons and the same number of hydrogens, but the structure could be different. Okay, so if it has a different structure, then it's going to have a different name for that compound, but it will still contain the same number of carbons and the same number of hydrogens. So now let's take a look at some examples. All right, these are some examples of isomers, okay? And this is using butane. If you remember, the prefix but means 4, right? The prefix but means 4, and it ends in ane, meaning that this is an alkane that has single bonds between the carbon atoms. So this is your formula for butane, C4H10. So it has to contain 4 carbons and 10 H's, all right? And just so you know, on this lesson, it's written correctly on your PowerPoint notes, but I just kind of scribbled out where they messed up in this program where the methyl group was, so I drew it in correctly there. Okay, so butane, 4 carbons long, so let's count this one. So this is just a normal straight chain. 1, 2, 3, 4. So it has 4 carbons. Then you can add up all the H's. 3 plus 2 is 5, 7, and then plus 3 makes it 10. So it has 4 carbons and 10 hydrogens. So that's butane. Now, if we want to create an isomer of butane, we still have to maintain 4 carbons and 10 H's. So one of the ways that you can create an isomer very easily is to kind of take one of these carbon groups here that's on the end and kind of just move it in the middle somewhere, okay? But then you have to go back and make sure you draw all of the carbon bonds correctly. Remember, carbon has to have 4 bonds coming off of it, okay? So then you would just adjust the number of hydrogens and where they're placed based on moving one of those carbon groups, okay? So if we moved one of those carbons over there, then it would look like this, okay? So let's see, it has to still have 4 carbons. 1, 2, 3, 4, and then it has to have 10 H's. So 3 plus 3 is 6, 7, and then plus that 3 makes it 10, okay? So notice the chemical formula is still the same, but the structure is different. So therefore, it's going to have a different name. So the name for this one is 2-methyl propane. Prop means how many carbons? 3 carbons. So this carbon chain is 1, 2, 3. Or we can also count it in that direction. Or we can go in that direction. So no matter which way we go, we still end up with 3. So if you remember your rules for naming, you have to find the longest chain. So the longest chain is in this one is 3. Then you have to figure out which direction to count it. You can go this way, 1, 2, 3, okay, where the branch comes off of number 2. Or if you count it in the other direction, it's still coming off of carbon number 2, okay? So that's why we have a 2 in the front there. And then you name where or what the branch is coming off of that carbon, which is a methyl group, because meth means 1. So this branch contains 1 carbon. 2-methyl propane, because the chain is 3 carbons long. Okay, so that is what an isomer looks like. All right, so now I want you to draw 3 isomers for C5H12, and you have to name each one. So you might have to get a little creative in terms of drawing your isomers, okay? Make sure when you draw your isomers that you move the carbon group somewhere in the middle, okay? Don't move the carbon and stick it back on the end, but you draw it in a branched position, okay? You can do a straight chain, a straight carbon chain, and that could be one isomer. So that could be one, and then from there you got to get a little more creative. Okay, so this is something that you should try on your own, and then go on to the next slide to check your answers to see if you were on the right track or not. Okay, so then let's take a look at what the answers are. Okay, so these are 3 possible isomers for C5H12. So if you count all of the structures, you should go through and double check to make sure they all contain, let's just write it down here on this slide so you remember it's C5H12. Okay, so carbon 1, 2, 3, 4, 5, and then it just has all the H's attached. 3 plus 2 is 5, 7, 9, 10, 11, 12. Okay, so C5H12. Notice here in the front they put an N and they called this n-pentane. The N in the front just means like normal straight chain. Okay, just a normal straight chain. You can leave the N off. You don't have to put N in there, but just in case if you see that like in a textbook or something, you're wondering what it means, that's what it means. It just means normal straight chain. Okay, now if you take one of these groups here, one of these carbon groups there, take it off of the end and move it into onto one of these middle carbons, okay, then you still end up with 1, 2, 3, 4, 5 carbons, and then if you add up the H's, 3 plus 3 is 6, 7, 9, and then you end up with 12 H's. Okay, then when you name this one, you're going to count it in this direction so that the carbon here, this will be number 2, because we would count it as 1, 2, 3, and 4, right? So that this branch would come off the lowest possible carbon. Okay, so then let me just number this so you can see it easily and how they named it. So off of carbon 2 is a methyl group, right? Because meth means 1 and that branch only has 1 carbon. Then the chain is 4 carbons long, so it's butane. So 2-methyl butane. All right, now we need to come up with a third isomer. So this one you had to get a little creative. Notice that you could put 2 branches on the same carbon. Okay, so we need to find the longest carbon chain, 1, 2, 3, if you count it like that. Even if you go down like this, it's 3. If you go like that, it's 3. So you have to look at all possibilities. So no matter which way we count it, it's still going to be 3. And also, since this one is pretty symmetrical, the branches, no matter which direction you count it, would come off of number 2. Okay, so since there are 2 branches, one here and one there, off of number 2, that's why the 2 was listed twice as 2, 2. Okay, and since they are both methyl groups, okay, and there are 2 methyl groups, so we add the prefix di. So 2, 2, dimethyl, and then it's 3 carbons long, right? The chain is 3 carbons long, so that's why it's propane here at the end. So 2, 2, dimethyl propane. Okay, so that is everything on isomers. That is what I want you to know for isomers. Be able to understand what an isomer is and how to recognize an isomer. Okay? All right, so that is everything for today. See you later. Bye.